Remember, as you're going through these, you got to switch to your custom tabs. The custom tabs is found by hitting the second button plus the home key. So if you hit second home, you get your custom tabs. Then you hit the solve tab, which is F3. And then you hit the solve template. And so even though we're doing X, Y, and Z here, the most we can enter on our own is the 2. And so you'll have to make adjustments to this. So if we just start typing our equations in right after the parentheses, we get X plus Y equals 2, and with the spacing, 2Y minus Z equals 0. And now we're going to have to put our own and. Remember, alpha lock it. You can either click the white alpha button twice, or you can hit second alpha to lock it just on the 1. But the space is this change of sign key, then type in the word AND, and then space again. And now you can deselect the alpha keys, type your remaining equation, negative X minus Y plus Z is equal to negative 1. And make sure on your leading negative for the X on that last equation that you use the change of sign key, not the subtraction key. And now we still need to make one more adjustment because we have 3 equations with 3 unknowns. The template set up is just 2 unknowns. So we do need to insert comma Z inside here to add it as our 3rd unknown. Once we do all that, we can hit enter to get our solution. And it's just a matter of writing what we have. So the X value was 3/2. The Y value was 1/2. And then the Z value, if we click up to scroll through, is 1. And so the way that I probably ask you to enter these is I might ask you to enter it in this form, and I might say X, Y, Z. And so when you enter this, you enter it as an ordered triple. We didn't graph any of these 3-dimensional plots, but you simply take 3/2, followed by 1/2, followed by 1, close it off, and that's how you would enter your information. Okay. So really that's the only review I want to do on Chapter 3 unless you guys have any questions about that. Were there any questions on Chapter 3? Okay, this is one that you should be able to do by hand. Okay, and when you add and subtract matrices, okay, you can just combine their corresponding parts. Okay, so you know that this x plus 1 has to be equal to this minus 15 plus 1. And so when you look at that and solve for x, here you cancel the 1s or subtract a 1 from both sides, so you get x is equal to negative 15. Okay, for the y, it's the same thing. You find the corresponding locations, and you say 8 is equal to y plus 1. So when you solve for y, subtract a 1 from both sides, you get your answer to be 7. So again, it winds up being pretty straightforward. It plugs directly into solve. Okay. It's easier to solve this by hand than to try to enter all this information in your calculators. I would suggest that you do this type of problem by hand. Okay, so this is just a matter of setting it up. Remember, your matrix keys are under this math key. Second, number 5. Matrix is the 4th set. So the determinant is right after that. And then just enter your matrix. So bracket 4, 0, 1, semicolon to move down to the next row, 1, 5, 3, semicolon to move to the last row, 2, 2, 0. Close off your bracket, and you have to close your parentheses to end the calculation of the determinant. And when you do, you get your answer to be negative 32. And remember, the way that this would be written is, it would either be the determinant of that whole set, or the other way that you might see this is the vertical lines. 4, 0, 1, 1, 5, 3, 2, 2, 0. If it's set in these vertical brackets or vertical bars, that refers to the same thing, the determinant of that matrix. All right, so the calculation for this is plus or minus 1/2, and then the determinant of these points set up in their own rows, and then the last column is going to be all what? Ones. Okay, so if you take that calculation, so if we take 0.5 times, again, if we go to our math key matrix number 4 and determinant number 2, and enter our matrix, we have -1, 0, 1, -3, 3, 1, and 0, 4, 1. And close it off, end of the matrix, end of the determinant. When I hit enter, I get -5.5 as my answer. Now, remember, this is a plus or minus 1/2. It truly you could think of it as just the absolute value of this solution. So our answer is going to be positive 5.5, or the 5.5. All right, anybody given any thought as to the user-defined function for this? Think it would be a hard thing to do? Think about what you have here. So you have 3 points, right? You have point A, which is H1, K1. Point B, which is H2, K2. Point C, which is H3, K3. And you see that your calculation is basically, because plus or minus, it truly does wind up being the absolute value of this whole value. 0.5 times the determinant of, and then our matrix is just H1, K1, 1, H2, K2, 1, H3, K3, 1, close the bracket, end it, okay? And that's all you would have to do. So basically, if you said define, and let's say we call it try area equals that calculation, and then you put in the order of inputs before your equals. So if you put try area parentheses, and then you just put all of those inputs, H1, K1, H2, K2, H3, K3 equals this calculation. You would have to close off your absolute values at the end. That right there would allow you to calculate the area just by entering the points. Okay. Again, I'm not going to go through it, but that's basically the process that you would use. All right, 2 last things to review. Yeah.
You said that you would set both sides. Like
No, don't. You don't need to set the equal would just be if you say define and then give it a name, like try area, and then order your inputs. So then just put parentheses H1, K1, H2, K2, H3, K3, all separated by commas, and then close that off as your order of inputs, and then put equals, and then absolute value of 0.5 times the determinant of this whole set of matrix, and then close it off with 2 parentheses. You should get, that's all you need to do. You don't have to, like, the setting equal to is the calculation of it. Your strokes do you need to find the inverse? You take your matrix to the power of -1. Okay, so if we set this up, take our matrix, and we just take 4, 5, jump to the next row, 3, 9, close it off, all to the power of -1. We get our answer of 3/7, -5/21, -1/7, and 4/21 as our answer. So remember, this is a case where you need to think in terms of finding the inverse. So if you let this be A and this represent B, in order to isolate and solve for x here, you need to multiply both sides by the inverse of a, and you have to multiply it in the same order. So the inverse needs to be on the left side for each of these. And so doing that creates a value of 1 here, so you get x is equal to, and so really what you're going to wind up doing is you're taking the inverse of this, and you're multiplying it by this whole matrix here. So if we take the inverse first, so set up our matrix. Uh-oh. Hang on here. Okay, so if we set up our matrix on this, so in our brackets, 1, 0, semicolon to get to the next row, 6, 2, close the brackets, all to the power of -1. So there's our inverse of a. And then we're going to multiply that quantity by this whole thing b. So in the brackets, we have 10, 6, 8. The next row is 4, 12, 2. Close that off. And when we multiply that through, we wind up with our solution, which is 10, 6, 8, and 32, 24, 25. So that would be our value for x, the whole matrix for that.